Dr. Pam Marrone, she would be talking on the biology and chemistry of bioinnovations. Akash, please play her thing.
Hello from Davis, California, where it's finally getting some needed rain, and it sure is raining right now. Thank goodness, both the farmers and the reservoirs and everybody needs it. I'm Pam Marrone, and I'm here to give you a short update on what's happening in biologicals for soil health and regenerative agriculture. All three categories of biologicals are rapidly growing. Biocontrol, bioprotection, or we call them bio-pesticides in the US, but we're trying to change the name to bioprotection. It's the largest segment and growing between 10 and 20% per year. And biostimulants for reducing crop stress and increasing crop growth. Also multi-billion-dollar and growing double digits. Likewise, bionutrients, as we want to reduce chemical fertilizer pollution, phosphate and nitrate pollution, growing very fast as well. All kinds of startups and companies in all of three areas. Very exciting, dynamic industry right now. Why is the rapid growth? Because these products offer value, better ROI, especially when integrated into traditional practices. And they can be replacements, but also can go on top of and integrated into all the other tools that we have. And great for organic farming, but often these biologicals get pigeonholed into organic farming. They're great for organic farming, but they're not just for organic farming. In fact, 70% of all biologicals are used in traditional, conventional agriculture. We have so many more tools, molecular tools, formulation, manufacturing, science to drive these products to a higher performance, and that's happening year by year. Growers are increasingly aware of these products and have more knowledge about how to use them, but this is the #1 barrier for adoption right now, and I'll talk more about that. As pests develop resistance globally, these products have typically complex modes of action for resistance management. Spray right up to harvest, don't have to worry about chemical residues. Spray in the morning, be back in the field in the afternoon, and being able to lower your labor costs, which is a very important issue these days. Most growers I talk to still say that chemicals don't solve all of their needs, and they still have a lot of unmet needs that they would like to have solved. And increasingly, biologicals are seen as a part of the solution to lower agriculture's carbon footprint, increase soil health, and meet consumers' demand for sustainability and transparency. The consumer, which then drives the food channel, retailers, this is a very big issue. And of course, biologicals are a lot lower cost developed than chemicals. And I want to mention that there's such a very important for the user and investors and key influencers in the ag channel and the supply chain to understand that there's a very different business model for startups and small companies in this arena. Typically, large chemical or fertilizer companies, huge amounts of capital upfront, especially for chemical pesticides, and then several hundred million, 10 years of development, and then launch big. We're moving to what we call innovate at speed, or an agile innovation model in the biologicals, which I've used in all the companies I've done. And that is, you develop a product that fits a grower need. It's version 1.0. You get it out quickly into the market, and then you use your early adopter customers who love to help you continue to develop the product and give you feedback. And then that goes back into R&D and expands your label and your uses and helps you come up with version 2.0 and 3.0 and so forth, and allows rapid and continued innovation. And this is increasingly being seen as a model for certainly ag tech, but also can be applied to biologicals. The other thing that's definitely converging in biologicals is that the use of precision tools, ag tech, big data, is now being applied to pest management and crop protection in general, but also for pest management. So no longer is it just about products, but is then integrating those products with better spraying, smart sprayers, drone sprayers, vision guided sprayers, robotics, models predicting and real-time spore or pest detection, so that you can time biological sprays much better and faster than you could in the past for better results. And analyzing today, you no longer can have a product and say, I don't know what my product does to the soil. You're going to have to look at your soil analysis, your microbiome of the soil before and after application for your products, and so many other things. Very dynamic industry, the convergence of tech and bio. Soil health is complex, but there's a lot of new knowledge that's rapidly developing for biologicals. And it's very exciting to see all the knowledge that we have going to this area of soil health. We now know that plant breeders are going to have to look at the microbiome and what their varieties are doing on the microbiome in order to be the best plant breeder, because plants contain signaling molecules that signal, for example, mycorrhizae, the strigolactone chemistry. But there's lots of other molecules that affect the microbiome and change the microbiome that are produced by plants, and microbes signaling other microbes. We know that as well. So this is an area that I'm monitoring very closely. We have a lot more to know and understand about what's actually happening. But what we do know is that anyone as a biological practitioner is going to have to understand how their product affects the microbiome in the soil and plant and soil health. Complex modes of action of biostimulants are increasing, and biopesticides are increasingly showing the benefits to soil health. So as I mentioned, modulating the plant physiology, helping plants take up nutrients better, enhancing nutrient uptake, affecting the gene expression, modulating the microbial community in the soil. I'm seeing that there's an enhancement in some products that I've seen, enhancement of biocontrol microorganisms in the soil, activation of microbial interaction via various nutritional elements, and seeing that biological products can sequester carbon, and that's by affecting the microbiome. So lots of exciting things to affect the soil health, and papers coming out every day understanding this area. An example from my former company, I'm still on the board, an advisor to Marrone Bio that I founded in 2006, is a product that we've been working on, new species, genus and species, Muscador albus fungus, that produces volatile gases that control can control plant pathogens, insects, and nematodes. And when you put a new developing a new fumigant, everybody says, well, what does it do to the soils? Is it going to be better than chemical fumigants? And indeed, our bioinformatics expert did a microbial community analysis of Muscador albus SA13 strain, and found that it whacked out, reduced dramatically the plant pathogens, but left in place the beneficial microbes in the rhizosphere in the soil. This is very exciting. So this is the kind of data that every company is going to need as they develop new products. As I mentioned, you can breed for these signaling molecules that say, hey, come to the plant, microbe or mycorrhizae. And here's an example of where the soybeans were, United Soybean Board and USDA funded research to show that you can breed in these signaling molecules to attract mycorrhizae with dramatic effects on plant health, as you can see here from the slide. So what else needs to happen to further drive biologicals and bio-intensive crop production and integrated pest management? Well, there was a recent poll by polling farmers by Farm Journal in the US, and they found that 35% of, and this was several hundred farmers, see potential in using biologicals, but 41% said, I need to know more before using. 21% didn't have a clue, didn't even know. Okay, only 4% they said they see no benefit. So this is the fundamentally, globally, around the world, just was at the ABI meeting in Basel, Same thing, no matter where you are in the world, it's this education and knowledge curve that we have to get across in how you use these products on the farm. So it's understanding how to incorporate biologicals. It's not if they work, but how to make them work. So more education and training is needed. And focusing on prevention versus cure. Chemicals often are curative and chemical pesticides, whereas biologicals have to be used much earlier, both for insecticides and fungicides, because you can't, the modes of action are such that you can't wait for them, the pest or pathogen to build up. You need to get them when it's much earlier in the life cycle, and then they can provide you fantastic, wonderful benefits throughout the season. I think that wherever you are in the globe, and certainly in the United States where we have cooperative extension and influential pest control advisors and certified crop advisors that advise the farmer, when they have to get their license, we think proficiency or they become a part of cooperative extension advisor in the land grant university system. We think proficiency in biologicals needs to be absolutely critical and required part of their curriculum, and should be part of the tests that they have to take for their continued licensing. And how you do the trials on these products is really critical. Go beyond counting bugs and leaf spots. Because of their unique modes of action, marketable yields and quality, including nutrient density with biologicals, could be better than chemicals, often the same, but could be better than chemicals. But if you're just measuring the number of bugs on a leaf, now there could be a bug that is a pest on the leaf, but it's not eating, it's not reproducing, it's completely stopped from its life cycle, but it's still there and isn't dead. So if you count that bug, and then it's going to give you a false sense that this biological actually didn't work. And look at the season-long beneficial effects on soil and plant health. Very critical now that we really have a focus on reducing carbon footprint and soil health. And it's always important to go beyond small university-done plots and look at what the product does in a real-world, larger situation. So new holistic systems-based programs need to be developed. Many existing integrated pest management programs are outdated. They just don't reflect the products today, their unique modes of action, combined with precision tools and data available to today's growers. And we've just got to stop expecting companies to come up with silver bullets. We're talking about integrated programs that are needed. So therefore, we need pest management and crop production practitioners and agronomists, plant pathologists, entomologists to be systems integrators. That we're talking about holistic, systems-based, ecologically based programs, integrating all of the tools we have today. So we go from a chemical intensive agriculture where instead of chemicals being the base of crop production and you dial in biologicals only when needed, we now have biologicals as the base of the crop production and pest management programs. And you only use chemicals, this is a non-organic program, so conventional program, when needed. And organic will continue to be consumer-driven growth and expected to continue to grow. And we're moving from an organic system to a regenerative organic system. This is a huge trend, so that we now move up the continuum to ecologically based, bio-intensive and regenerative agriculture. So biologicals, ecologically based for both crop production and pest management, can address all the key issues in food production today. Growing more from less land, and affordability of food because of the increased ROI that biologicals provide, can address climate change and the need to reduce carbon footprint of agriculture, reduce chemical runoff and pollution of air, water, and soil, increase soil health, and provide a whole benefit to sustainability. Thank you very much.